Hi. So, now the next proposition we are going to discuss is called Rybczyński Proposition. Well, first we're going to state what does it say, and then there's going to be kind of a long road to actually demonstrating how it works in the neoclassical model. But let's start with what the proposition tells us. So, in a neoclassical framework with two final goods, two factors of production, and constant prices, so for now we are freezing prices of both goods, of the final goods, and increase in the supply of the one factors of production results in an increase in the output of the final good that uses this factor of production relatively intensively, and the reduction in the output of the other final good, provided both goods are produced in equilibrium. Okay, remember, now what does it mean? Remember that we are interested in, of course, long-run equilibrium. What does the Rybczyński proposition tell us is that in neoclassical framework that we've been discussing for last at least 10 videos, we can see that if capital in the economy is increasing, if the level of capital is increasing, this should lead to increase in the production of manufacturers and fall in production of food. Okay, look, this result is definitely not obvious. Why? Look, because if we have more capital, then technically we could produce more manufacturers, we can produce and more food, right? But actually what the proposition says that only the good that uses the in production process capital extensively will be produced in a bigger quantity, while actually capital will be diverted from the production of food, and production of food will fall. And look, of course, on the other hand, if the amount of labor in the economy is going up, I don't know, for example, our economy open borders, and we have an inflow of workers from other countries, we should expect that this will lead to the fall in production of manufacturers and it will raise the output in food. Again, look, with more people we could produce more of both, but actually this is not what we get in the neoclassical model. Now, the road to actually showing this result is a little bit lengthy, but it requires a little bit less mathematics than we did previously, because we will have to resort on many occasions to graphical illustrations, but of course it will be consistent with the model. But before we go to the tools, because we need to develop some special tools to analyze this problem, let me add one more thing. Because over here we also have John's magnification effects. Okay, so look, in case of John's magnification effect, we talked about relative changes, right? So here we can say that if capital, relative change in capital is higher than relative change in labor, what is going to happen? Well, production of manufacturers is going to rise actually by more in relative terms than capital, and of course from here we get that labor is growing actually slower than capital from our assumption. But here, as you can already expect, we will see that production of food will grow even slower than labor. Okay, and of course it works in opposite direction. If capital grows relatively slower than labor, we would expect that growth of manufacturing will be the slowest, then will be the capital, then labor, and then production of food will grow by the most. So look, again, this time we're not going to be proving it. I believe we spent a lot of time in the previous videos, and I don't want to make you suffer through this one more time. But please remember that this magnification effect also work in the case of Rybczyński proposition. Okay, so now that we know what the Rybczyński proposition states, we need to introduce some tools, some new tools that will allow us to actually show that what is happening in this neoclassical economy that leads to this quite peculiar result at first when you first think about it. And look, the tool we are going to use is called Egdworth Box. Maybe you heard about it in intermediate microeconomics, or maybe you will hear about it in public finance, but we need to use it here. But let's just start from the beginning. Okay, we introduced a tool called isopoints. Well, we've also probably seen it in microeconomics class, but how does it work? Okay, let's start with isopoints for manufacturing. Right? Okay, so on this axis we have capital, and here we have labor. Okay, now what those isopoints represent? This isopoint is showing us all combinations of capital and labor for which maybe, you know, let me just draw it a little bit differently. Oh, like this, it will be better. Okay, all combinations of capital and labor required to produce a given amount of manufacturers. Let's just say 1 unit of manufacturers. And of course, we can create infinite number of isopoints like this. And we see that the further we go from the origin, the more units we can produce. So the third isopoint here, for example, could be associated with 3 units of manufacturers. And look, so we remember that, of course, this gives each of these points gives us a combination of labor and capital that will give us exactly the same amount of output. Right, and look, we could also draw a very similar, actually even identical, coordinate space, but this time for food, right? Of course, isopoints for food should look a little bit differently. We know the production of manufacturers is capital intensive, while production of food is rather labor intensive. Okay? So we would have F equal to 1, but the logic, of course, behind this these ones is exactly the same. Okay. Now, the thing is, this is only showing us what is happening in manufacturing sector and what is happening in food sector, respectively, right? So, technically speaking, here we have labor used in manufacturing and capital used in manufacturing. Here, we've got labor used in production of food and capital used in the production of food. So, before, it was enough for us to treat those two separately. But now, as we are putting model closer and closer together to the end, we would like to somehow connect those two. And we can do it actually in quite easy way. Okay, so now, of course, how much capital do we have in the economy? Let's just say we've got K. Look, assuming full employment, so again, as I remind you probably every 4 or 5 minutes, this is a long run model. We have full employment. What does it mean for us? It means that capital, entire capital in the economy is used. Part of it in production of manufacturers, and the second part in production of food. Okay, and we can do the same for labor. Part of the labor is used in the production of manufacturers, and the other part is used in the production of food. Well, this definitely has a potential of integrating those two graphs somehow, right? So, how could we do it? Let's think about it. Okay, let me just let's just say again that here we have the entire labor in the economy, and here we have entire capital in the economy. Now, let's just say that we're going to start with manufacturers, right? All we have to do is to put a couple of isoquants over here, right? But, so, and look, how does it look? Look, if here we can say is the origin for production of manufacturers. And look, now, if I move in this direction, I'm using more labor in the production of manufacturers, and if I move in this direction, I use more capital in the production of manufacturers. But of course, look, in the economy, like the essence of economics is that factors of production, generally resources, are limited, they are scarce. So there's only given amount of capital in the economy and given amount of labor in the economy, right? We cannot use more capital than we have, we cannot use more labor than we have. So if we have full employment, then capital, if we use some amount of capital for manufacturers, we only can use rest for the production of food, and the same with labor. And this actually can allow us to connect those two graphs. Because look, imagine that I'm going to do something like this. I'm going to take this. I'm going to take this graph, this coordinate space, for food, me just eliminate food subscript, and I'm going to start rotating it clockwise, like this. Okay, so look, then I would have something like, in the second step I would have something like, for example, this. Here I would have K, here I would have L, and O, F, right? But I don't need to stop rotation over here. I can rotate it even more. And look, if I'm going to rotate it more, this is what I'm going to end up with. Here will be origin for the production of food. Here, as I go in this direction, there will be more and more labor used in the production of food, and in this direction, there will be more and more capital used in that production of food. And of course, look, now those isoquants will look a little bit, will look upside down, right? Like this. Not like this, but like this. Okay? Okay, so let me now just make a little bit nicer graph and explain exactly what is going to be happening. Let me just say at this moment that what you see over here is called Egdworth Box. Egdworth Box. So, well, of course you can, I hope you can clearly see why this is called the box, but now let's discuss it in detail, because this is a very important tool of the analysis, not just in neoclassical model of trade, but generally in any general equilibrium model in economics. Okay, so let's see how it is constructed. Okay, first we have the box, and it goes like this. Okay, hope it's rectangular enough. Of course, it doesn't need to be square. We don't need to have exactly the same amount of labor and capital. But look, we will have two origins. This is the origin for manufacturers, and this is the origin for food. Okay, look, here, and exactly the same way here is labor, while here and here is capital. Okay, and look, how will this work? Look, if I move in that direction, the more and more labor is used for production of manufacturers. If I move in this direction, more and more capital is used in production of manufacturers. But look, we've assumed full employment. Those relationships hold. So what does it mean? Look, if I use more and more labor in production of manufacturers, it means I'm using less and less and less labor in the production of food. And the same is with capital. So look, actually, here, when we move from this point in this direction or in this direction, we are using more capital and labor in the production of manufacturing. Here, on the other hand, if I move from this point over to the left or down, it means I'm using more and more capital and more labor in the production of food. Now, so knowing this, look, it makes a very clear picture that if I use, if for example, economy is at this point. Okay, let's do not discuss, let's forget about isoquants for now. We are at this point. What does it mean? Okay, look, this point is showing us the division of labor and capital. So basically the distribution of labor and capital between the two sectors. Okay, so look, if we are at this point, let's call this point A, it means that this much labor is used in the production of manufacturers, and this much capital is used in the production of manufacturers. But from those two relationships, assuming full employment, well, of course, we can deduce that this much labor is used in the production of food, which is like we could see on this axis, because of course those two are identical, and this much capital is used in the production of food. Okay, this actually explains, I think, quite a lot. So we see that depending on where this point A is located here, we will have different division of labor and capital between two sectors. Okay, so I think at this moment we are getting to be ready to introduce isoquants to this graph. But look, I'm actually gonna start drawing our graph like this, and I'm gonna draw a line going from one origin up. I'm sorry. Over here. Let's don't worry about this line. I know what should be next, and if I'm not gonna draw this line first, I'm not gonna be able to graph it properly. So forget about what this line represents for now. It is important, and we will be discussing it in detail. But for now, let's just say there is some line. I need to use it because otherwise, you know, I'm not a computer. I cannot draw everything perfectly. Okay, so now let's draw some isoquants. Look, of course, it works like this. The further and further we are from the origin OM, the more and more manufacturers we are producing. Over here, on the other hand, the further and further we are from the origin, with isoquants, of course, the more and more food we are producing. Okay, let me just draw a couple of isoquants for food. Okay, let's just say we've got three different isoquants here. Okay, let's just say that this is isoquants F9, this is F8, this is F7. So look, what this is, so this isoquant represents all the combinations of capital and labor required to produce 9 units of food. This line represents all combinations of capital and labor required to produce 8 units and 7 units. And you see that further and further I would go into the OF point, so origin for the food sector, the closer, the less I would produce. And the same is of course true for manufacturing. Now, the further with each the further and further I will go with each isoplant for manufacturing, the more and more units of manufacturers I can produce. Okay, so now let me just add some units. Let me just add some isoplants for manufacturing. Okay. So let me start with the first one. Okay, I know it's not perfect, but okay, I'm standing by it. It's not that bad. Okay, and let me just draw another one so you get the sense of how everything works over here. Okay, and look, let's just say that this isoplant represents how all the combinations of labor and capital required to produce 2 units of manufacturing. And this one, of course, is further from the origin. It represents how much all the combinations of capital and labor required to produce 3 units of manufacturing. Okay, so now we probably, even from this graph, you can guess what is this line representing. But before that, let's consider different positions we can be. Okay, so look, let's just say that I am at point A. Now, is this combination possible to produce within this economy? Of course. We have enough capital and labor to produce this much, right? Because look, we clearly see that I can produce 7 units of food and 2 units of manufacturing if I'm going to be at this point, right? But is this point efficient? Remember, we're assuming that companies are minimizing their costs. So every combination that we are going to consider here must be an efficient combination. And look, this combination is clearly not efficient. Why? Because look, if we would be at this point and move to point like point B, what would happen? Look, we would still be able to produce 2 units of manufacturers, but we would be able to produce 8 units of food. So clearly this combination is not efficient. Now, but there is a second possibility. Look, we can clearly see that we can still produce 7 units of food, but 3 units of manufacturers if we move to point C. Okay, so this should tell us a little bit more. Look, if we are assuming that the production is to be done in an efficient way, this means that points like A will not be optimal points. The optimal points were actually always going to be at the point of tangency of the isopoints. And now, I hope you can see that this line that you see over here is actually the line that represents all points like that. This line actually, if I would draw another isopoint for manufacturing, for example, 1 unit, this line connects all the points of tangency. So look, those are all the points at which the resources are allocated effectively. So they all represent the best usage of resources in the economy, in the production of food and manufacturing. And this line that connects all those points is called contract curve. And contract curve is going to be the topic of our next video. Okay, thank you for your attention.